Okay, so we are still doing Common Core. We'll be doing Common Core all year because that's just what the president wants us to do. So it is geometry for G, CO for congruence, and number 9. Number 9 deals with proofs. So we're going to prove theorems about lines and angles. Okay, that is our Common Core for basic. We'll be doing that for a while. Was it 2, 3? I think so. All right. Let's see if we can do this together without me doing the whole thing. We got 30 of us. With all of us, we could probably get it, okay? So let's tackle this. So number 1, what I do, the very first thing I do is I read the given, and then I try and mark the figure, okay? So given, I've got 1 and 2 are complementary. I'm going to highlight that word complementary. I know that means I got to add up to 90, okay? Prove 2 and 3 are complementary, okay? So I'm looking for things that are going to add up to 90 degrees. That's part of what I'm thinking. Okay, now, so 1 and 2, and I got the little box there, so I like the little box there. If I hadn't, I might have put it in there. So one of the things, if this 90 wasn't here, I probably would have put it in there, okay? Because I know that, you know, complementary 90 degrees, right? So I've got 1 and 2. So I also see something in my picture. Would anybody see anything up there? What about 1 and 3?
They're vertical angles.
They're vertical angles. So I'm making my plan, right? So 1 and 3 are vertical angles. So I know that, ready? If 1 and 3 are probably going to be equal, then that's probably going to help me somewhere along the line, okay? So you ready? Step 1. What do you think? The given, right? Everybody agrees? So let's go. Yep. Nice job, Katie. Angle 1, angle 2, complementary, given. Right? Nice. 2. The measure of 1 plus the measure of 2 are 90.
Definition of complementary?
Yeah, definition of complementary. And what happens in a lot of proofs is you make a statement and then you follow with it. Because we want to be this logical here, and we go from here to here, from here to here. So we say they're complementary. Then the next step is to say that they add up to 90. Well, that makes sense because of, thank you, Claire, definition of complementary angles, okay? And we can abbreviate. As long as you guys write it well enough that I know what you mean, then you're good to go, okay? Okay, 1 is congruent to 3. It is the vertical angles. Good job, Shayla. It is vertical angle. So we can go VAT. That abbreviation's okay. VAT, there's a few of these we can abbreviate. VAT, vertical angle theorem, okay? Nice. So now what I like to do is mark my figure. So I'm going to go and actually go and mark that 1 and 3 are equal, right? Okay. Step 4. Now this is the one that you got to get used to. I go 1 and 3, and then I say 1 and 3 again. I went congruent to equal measure. Now this is the one that you're going to have to just learn. I said the almost exact same thing. But if they are congruent, then obviously their measures are equal. Anybody remember what that one is? It's the definition of congruency. And that's the one we're going to have to most kids forget that one. It's the definition of congruency. And here's why. If they're congruent, they have the same shape. If they have the same shape, obviously they have the same measure, right? Okay. Now the reason you have to do that is because when you do your substitution, you've got to make sure that it says the measure of. That's why we did this step, because the next one is going to be a substitution. So instead of writing the measure of 1, we can put 3 in its place, right? So if we hadn't done that, then our substitution wouldn't be a good substitution. So obviously, step 5, I just told you, which is a substitution, yeah. You could even call it transitive technically. They're kind of almost the same. Okay, the last thing is obviously has to be this. Has to be, right? Because that's what we're trying to prove. So even if you have no clue what we're doing, you do know the first step's the given. The last step has to be what we're proving because we're at the end. So we're going to just say that angle 2 and angle 3 are complementary. And what's the reason for that? What do you think?
Definition of complementary.
Yep. Definition of complementary. Okay, so be honest. Sideways, kind of up, little up, totally down. I want to see. Okay, all right. All right, that's not bad. That's better than yesterday, because yesterday we were probably here, right? And today we're kind of sideways, and Megan's kind of going like this. It's all good. Okay, let's look at number 2. Okay, number 2. If I take a look at number 2, then given AFB is congruent to EFD. So it's marked already for me. I like that. If it's marked, then I know that that angle is equal to that angle, okay? And I want to prove that FB bisects angle AFC. All right. So if it bisects, what I probably am going to have to do is somehow be able to say that these two angles are equal, okay? I've got to somehow be able to say these two angles are equal, because if these angles are equal, then it would mean that that has to go right through the middle of it, okay? That's my plan. Somewhere along the line, I want to be able to say this angle and this angle are equal, because that would make that one go through the middle, right? Okay, so step 1. What do you think? Step 1 is the given, right? Angle AFB is congruent to angle EFD. Given, right? Good. And I've got it marked, okay? Now step 2, EFD. Let's see, EFD is congruent to BFC. Yeah, I would totally agree with that. Let me mark it in a different color. So I got it marked. Okay. So we're saying that this angle is equal to that angle. I agree with that. I do. I totally agree with that. Why?
Because it's a vertical angle.
There you go. Vertical angle theorem, or VAT, right? Vertical angle theorem. Good. All right. All right. So if I'm as cool as Mason's and Mason's as cool as Kurt, then Kurt's as cool as me. So if, you ready? If this angle is equal to this one and this one's equal to this one, or if, let me mark them. If I mark 1, 2, 3, it's easier to see. If 1 is equal to 2 and 2 is equal to 3, then 1's got to be equal to 3. Would you agree with that? So all of a sudden they go AFB is congruent to FBFC. So if 1 is equal to 2 and 2 is equal to 3, 1 is equal to 3, I agree with that. What's the reason? Transitive. You could also say substitution. They are kind of interchangeable, but I'll go along with transitive. Cool. So now here's the thing. We've got these two angles equal to each other, right? We've got this angle equal to this angle, right? They are equal. So basically this has got to run right through the middle of it, right? Now we go one more thing. We say the measure. So we go AFB. So we say the exact same thing except we say the measure, right? That's that weird one. Do you remember it now? Definition congruency. Good. Definition of congruency. Good. And then finally, what do we have to prove? Yeah, so you got to put that right there. You agree? The very last step's got to be there. So we're going to go FB bisects angle AFC. So what do you think we could say? Why? Yeah, nice job. Definition bisector. Makes sense, right? We know it goes right through the middle, and a bisector goes right through the middle. So definition of bisector. Okay. All right, give me a thumbs up. I want to see it. Be honest. Okay. Good. Good. Okay. We got more going up. I like it. We're doing our job. Okay. We got a few sideways. That's okay. Remember, I told you for some of you it may take a month. Seems like a long time. Well, we will not do proofs all year. I promise. We won't. Hey, don't feel bad. When I was a kid, sitting in geometry a long time ago, geometry was all proofs. Every single day was proofs. That's all we did was proofs. I know. Disgusting, huh? And then they got rid of proofs completely for quite a few years. And then I was like, okay, this is much better. And then they brought them back. Anyway, turn the page. Here we go. Last one. Okay? Let's see if we can do this one, okay? So again, let's go ahead and take a look. So I'm going to mark what I can. AB is congruent to EF. So I want to mark it. I'm going to mark it AB. So this one is equal to this one, okay? If I can mark my figure, it helps. And I like to use different colors. You guys can use whatever you want, but I like different colors because sometimes I'll have other things, like on this one, I'd have other things equal, so I like to use different colors. Just help me, okay? So now, midpoint keyword, highlight that. Midpoint of AC, okay, that's a keyword. And midpoint of DF, okay? So I want to prove AC, which is the whole thing. I want to say that this segment is equal to DF, that whole segment, okay? All right, so step one. What's step one?
The given.
All right, so let's go and put AB equal to EF. And I will put midpoint. I'm not going to squeeze it all in here. B midpoint AC. I'm going to abbreviate in E midpoint of DF, right? Right, given. So I squeezed it all in there. It's going to work. All right, so all of a sudden, let's see what it's saying. AB. So here's AB and BC. They're saying these two are equal. And we're also saying DE is equal to EF, okay? Well, why do you think? Why would these two be equal? Unless we have a mid...
Because we have a midpoint.
Right, right, you guys agree with that? We got a mid. If B is a midpoint, then that's got to be so by definition of a midpoint, okay? So I'm going to mark that. Let's see, how about green? Okay, so I'm going to say this side's equal to this side. And I can say that this side is equal to this side. Okay, so far so good, right? Okay, now we go from congruent. We say the exact same thing, but we go from congruent to equal measure.
Definition of congruency.
Nice. Definition of congruency, right? All right, now we're going to go AB plus BC equals AC. Well, that seems obvious, but we're going to say AB plus BC equals AC. And the reason we have to say that is what are we trying to prove? Right. So we need to make the whole entire segment, right? So if I add this piece plus this piece, I get the whole thing. Or if I add this segment to this segment, I get the entire segment. What do you think I'm talking about? How about segment addition? Okay. And it is a postulate, but who cares, right? Segment addition postulate. Again, if you don't put the postulate, don't even worry about it. I've been doing this way too long, so I know it's a postulate, okay? And the same thing here. They're going to say that DE plus EF equals DE, okay? Got it? Okay. Now, the next step, all of a sudden we go, and we should have an additional step in here, but we're going to go to 2AB. 2AB equals AC. Okay, well, if these are equal, right, if these are equal, then this is equal to this. So we're going to add them together, okay? And we're going to say that 2E, 2 EFs, 2 of these is equal to all of this, okay? So it's basically, it's going to be addition and substitution. So I'm going to put addition and substitution. I need to rewrite this problem because it is really another step. All right, this one's hard. Now, AB is equal to EF. How did that happen?
That's the given.
They snuck it in. Yes, question, Maria. Oh, you're stretching? That's okay. Okay, they snuck it in. Do you see the given? Okay. So then the next thing is you're going to go to 2AB plus 2AE. So all we did is we went from here to here. What do you I mean, it's just, it may not be that obvious, but what did they do from here to here? Same thing except for now they're twice as big. Same thing except for they're double. Same thing except for I multiplied both by 2.
Definition of multiplication.
Yeah, just multiplication property, right? How about just multiplication property? Now, we're going to make a substitution, right? Up here, 2AB, right? Check it out. 2AB is equal to AC. Do you see it? 2AB is equal to AC. And we're going to make a substitution. 2EF is equal to DF, okay? Or that should be a DF. That's a mistake. DF, okay? And that has got to be a substitution. Okay, finally, let's go ahead and put what we have to prove, which is AC is congruent to DF. Okay, now we went the other way. We went from equal to congruent. Went from, said the exact same thing, equal to congruent, equal to congruent. What do you think that is? Yeah. Okay, here's the good and the bad news. Okay, the good news is I will never, ever, ever give you a proof this big on any test. That's the good news, okay? The bad news is we'll probably still do them for homework, okay? So, all right, so homework today. And I want you guys to try and do these on your own. It'd be better if you did them without me.